Hello. Hi. So, hey, Lex. So, my name is Peter Hollander, and this is a talk on getting into hardware development in the industry. So, my name is Peter Hollander. I'm an enthusiast turned hardware developer just about in the past 2 years, really. I'm working on the Talaria locomotion wearable, and we've got that down in the expo hall downstairs. If you guys would like to try it out, we're going to be shooting for a working demo right around the end of lunchtime, so feel free to come stop by, chat with us. And I'm going to be giving this presentation, introducing you guys into hardware development, and citing my own experience with going from not knowing any programming or electrical engineering to now bringing a commercial product to market in just about 2 years, being in the process of bringing a commercial product to market. So the first and foremost important thing is that you need to expose yourself to the medium of virtual or augmented reality. And you guys are all here at this conference, so I think you've all got that one checked off the list. For a while, I was interested in VR, and I was watching lots of things on television about it, and just really fascinated as an enthusiast. And I thought I had some great ideas. The moment I got into an Oculus Rift, or the moment that I got into a Vive, I knew that a lot of those assumptions that I'd made really were not necessarily true once you were experiencing things. So for a while, I was trying to work on a treadmill kind of design, and for reference, what our hardware is, the Talaria hardware is, it's a locomotion wearable, so you have pressure sensors under your feet, and when you're walking in place, it lets you locomote through the virtual world. We were trying to make a treadmill for a while, just kind of conceptualizing it. And then the moment that I stepped into the Vive and I had room scale VR, I knew I could not possibly bind myself to a treadmill and had to really rethink how we were going to approach that problem. So we'll get into how that one got tackled soon enough. So the way that I would recommend everyone get into hardware dev is find out what is something that you're passionate about, that you'd be willing and interested to solve, and it's not going to be work, it's going to be play. That's going to be the best way that you can learn, is by always enjoying what you're doing. And my problem was that I didn't have natural, large-scale locomotion in VR. Teleportation felt discontinuous, sliding motion felt nauseating, and then auxiliary hardware was just too much, too restrictive or too expensive. So for early research, just before you dive into any of the physical electronics, programming or coding, or assembly, you're going to want to just start researching and seeing how are other people solving this problem right now? What are the current solutions out there? And what are some ways that maybe other industries are solving similar problems? Because not everyone's going to think about everything the same way. For me, the locomotion scene had a lot of software and hardware solutions. The software, like I said, were teleportation, dash, sliding, joystick in the really early days. And so then the hardware solutions were the omnidirectional treadmills that were military grade, or then the omnidirectional slide mills that were like the slippery dishes that you had the harness for. You had some inertial sensing, things like that. Giant hamster balls were one of them. And so once you are familiar with all of that, I'd say at that point, it's pretty good to purchase your first development kit. Assuming that you don't have any prior knowledge of electrical engineering, you're going to want to start familiarizing yourself with how electricity flows, what some basic components are, resistors, capacitors, inductors, how LEDs work, why they're only one directional, all that good stuff. And from that, you also want breadboards, hookup wire. I can talk to you after the talk if you are a little lost on that and you want to get some guidance on specifics of what to buy. My introduction with electronics started a few slides later, to be quite honest. In hindsight, it would have been way more efficient for me to have started at a point like this, but this is kind of a post-mortem of that as well, so take from my mistakes and definitely start out right with this. So then for the next step, I'd say go for researching and learning just the theory behind electronics, because you want to actually understand what's going on in your circuits that you're making. You don't want to just draw out a schematic, make something, and then it's working. You want to, if it's not working, you don't know how to debug it if you don't know what everything's actually doing. And that's going to definitely come from implementing it into different scenarios for the solution that you're passionate about, because if you're passionate about this solution, if it's not work, if it's play, then you're going to be fine spending the extra troubleshooting time on solving how to overcome any of the issues that might be presented to you from not understanding what a capacitor actually does, why does it hold a charge, et cetera. So then we'll be getting into examples of my development in just a couple more slides. You're going to want to purchase your first microcontroller once you're finally familiarized with the theory and the physical construction of different little circuits. Just once you can have a button that turns on and off an LED, once you play with some timers and make some blinky circuits and all, that's the hello world of the electronics world, by the way, then you're going to want to get a microcontroller. Common microcontrollers out there, the two best ones are Raspberry Pi and Arduino. We developed on Arduino for the early stuff, for Talaria. And then what I started with was, I'll show this in 2 slides. It was a thing called the iPack, which you can program very easily, very usable user interface that it's meant for arcade machines. You can hook up any digital inputs to it, and it'll output keyboard signals to your computer. And that was a really easy way to just get started, jump into Python, and start hooking into those inputs and letting it get used inside of Unity and things like that. And you need to definitely, I'm guilty of this one, you need to invest the time in the basic tutorials. As much as you might it might feel like there's redundancies, or you might feel that you're beyond those first 3 tutorials, there's going to be little nuances that everyone introduces, and you're going to want to really make sure that you're covering everything so that you're not lost from the foundational stuff later on. This is, again, kind of the post-mortem aspect of it, that I didn't start out jumping in with the proper education and hardware electrical engineering knowledge, and so there was a lot of moments where I was fish out of water. So having all of this under your belt is definitely going to be good for you. And then you're going to want to validate your learning. Once you learn something, don't just move on to the next thing. Take your circuit apart and rebuild it. Make sure that you understand how to write the schematic, make sure that you understand how to transmit that information, and make sure you understand how all the components that you just learned about are working. So you're going to want to start solving your problem. This is something that in the last month, as we've been approaching the conference and getting our hardware demo ready, that I am definitely learning this one the most, that you want to solve things the easy way and not the perfect way. You want to be approaching things as proofs of concept in the prototyping stage, not as a complete functional work. For us with Talaria, our focus was we wanted to make something that can capture user input of the feet, and when the heels are alternating, that's going to create people, that's going to let people walk around within virtual worlds. So instead of jumping straight into figuring out how to make flexible pressure sensors, ergonomic straps, wireless technologies, et cetera, we just made this thing that looks like a disc jockey board. We went to Bed Bath & Beyond, got some spice racks, and got some arcade buttons off of Amazon, and then went to Lowe's for the plywood. And then when you step on these buttons, it sends out keyboard signals, and then I started to learn how to code for coding in Python. And that'll be the same workflow of investing time in the basic tutorials if you're not familiar with programming yet. And then I was able to, I think this was on a DK2, and I was able to start injecting things. I think I did it into the Stanley Parable. So that was a fun one. No interaction with the hands, you just had to walk around. So that was a good experiment. And then you want to identify what needs improvement after you've made these initial prototypes. Once you're comfortable with the stage that they're at for proving the specific concept that you're trying to look for, start getting feedback. So this was done in my university dorm room, and the feedback that I got from it was that it felt a lot better than using a joystick, which I suppose isn't saying much. Joysticks can't feel that great in VR, but you've got, the biggest input that I got was that somebody took one first step and ripped off the headset and almost threw up on my carpet. So that was a pretty telling sign that I had some work to do there, but it was enough that I was able to use this hardware on just a normal desktop monitor, not even with a VR headset, and I was able to walk through, I think I was using Gone Home. I was able to walk through that, and I felt a sense of presence looking at my desktop monitor, just kind of trotting in place there, and I felt like I was having that movement through the world because I was using my legs for the movement. So you're going to want to research and learn after you've identified what's going to need improvement here, once you've gotten all this feedback. And this is where this kind of loop of an iterative process and iterative prototyping starts to come in. For me, walking on the button board was great to prove the connection between your feet and walking, and like moving through the world. But now, okay, people are getting really sick. Let's try to learn things about the vestibular system. Let's see what this whole issue with balance and motion sickness really is. And why do we have to be restricted to something like a button board? What if we put these things just straight onto your feet? So then you start iterating. You start editing your prototyping process. And something that we did here was, again, very hacky, very quick. That's 2 pieces of plywood with tinfoil on the backs of them and sponges in between them. These are just some, you just can walk, and it's basically taking the buttons that were under your feet, and now they're on your shoes. It's this kind of Frankenstein's monster of electrical cable. But I was able to walk around with these as well, run around, and it was a lot more accessible than having to be restricted to a button board and having to be sitting down. You can do this standing up now. So slowly but surely, making progress. And then, again, like I said, it's a cyclical iterative process. So you're going to want to just continue iterating, identifying what needs improvement, and researching, and just do it again and again and again. And it's going to be a lot. And you're going to want to make sure, like I said, you want to be passionate about what you're doing, because you want to make sure that this is play and not work. Because if it's work, then you're not going to necessarily give it your all. You're going to maybe want to cut some corners, and it's just going to kind of trickle down this whole cycle, and things might start to fall apart, or you might lose interest. So make sure that you're passionate about what you guys want to do. It's important. And so this is where we're at. As of August, we had wearables that strap on to your heels, transmitting wirelessly now. You can walk in place. And this is just me doing some little shooting and taking cover. And then you also have a little third-person mode here for comfort, so that there's absolutely no risk of motion sickness. And again, we're going to have this set up downstairs, a variation of this later around lunch. So feel free to come by if you want to give this a shot. So then, at this point, once you've gone through this cyclical process enough and you've been getting enough feedback, it's going to be like you're going to eventually hit a point where you're going to start wanting to share this with a lot more people than just your close friends or anything like that. And when you want to bring it to places like Vision, when you want to bring it to conferences, when you want to make it public online, it's important to protect your idea. Not necessarily if you want to have exclusive rights to it, but for example, we protected our idea because we want to make sure that nobody else can kind of gobble it up and bury it away. So that can be exploring the patenting process. That's something to look into. And if any of you are near that stage, by all means, come and talk to me after the talk. I'd love to give you a lot more information and resources on that. But you'll want to file a provisional patent, which you can do without an attorney, and for pretty cheap in the grand scheme of governmental kind of forms. And a provisional patent will pretty much say, hey, I'm working on this general idea, and within a year, I'm going to pay for the actual thing, so I'd like to protect myself. So at that point, we filed our provisional for Vision at last year, a few days before heading out in February, and that was really, really good for us because then we could openly talk about our hardware and not feel like we had to keep anything under wraps because we knew that once we filed the actual patent, it would be completely protected. And super important here, I think, for this industry is sharing your work. Right now, we're in such a unique place with virtual and augmented reality that I truly feel that this industry is collaboration over competition and progress over profit. We are collaborators that when we discover something, it's not a trade secret. When we discover something, we want to scream it to the heavens, show other people, ask other people to break it, and see what we can do with that and what we can learn with it. When we fail at something, we want to share that. We want to post about it on Reddit. We want to make fun of ourselves for it, and we want to make sure that other devs can learn from it and not make the same mistakes in the future. So, for example, I've got a blog going. These are just a couple of shots from what we've been doing with different hardware development, from Steam VR tracking to earlier prototypes. Got some virtual reality storyboarding up there. So I think it's really, really important that once you've protected your idea and it is comfortable for you to share this out to the heavens, like scream this out to the heavens, that you really should. Whether that's on Medium, WordPress, just having a good presence on Reddit, YouTube, get it out there. We're all interested, and we'll all learn from you, no matter how early on you are in the process. We'd all love to see it. So I've got a couple of example problems here now. So, like, if you can't solve any problems, sorry, I'm losing my place in my little notes here. So, if you can't solve a problem, my first go-to is always sleeping. Usually, when when you're passionate about something like this, pulling all-nighters simply for the sake of figuring out that one bug, that can be pretty easy to accidentally do. So you have to sometimes remind yourself that it's important to just take a step back, take a nap. And yeah, but aside from that, once you've slept, there's two options. Either the problem can't be solved, which is very unlikely. There's always going to be some roundabout solution in my experiences. Or you need to approach it from a different angle. So this can go back all the way to when I was saying, how are other people solving similar problems like this, maybe in other industries? Look to taking a step back and seeing, are you actually targeting the right problem? Maybe you need to go a few steps back in development. And like, also for hardware prototyping, make sure that the basics are still working. Make sure that your clock is still running. Just upload a very basic firmware file to your microcontroller and say, hey, turn my LED on, then turn my LED off, then do it again. And if that doesn't work, then it's probably not a problem on your end. It's probably a physical problem, and you need to get another microcontroller. But that's some, just general debugging kind of 101 skills. So if you've got some good troubleshooting and some good Googling skills, then you should be pretty okay here. Just make sure that you just keep on persisting through solving those problems, because it's very, very uncommon that there is no solution. There just has to be a different kind of a solution. So this is something that we've encountered before. What if somebody else solves your problem first? You are an independent hardware developer, most likely. You're just getting into the hardware scene. You're not going to have a whole lot of person power to be able to bring something to market in a matter of months. You're going to be developing something for a while and tinkering with it, making sure that it's really up to your standards. So what if some larger name company or something comes out with something and releases your idea, the same idea that you're working on, under their own fruition, and it's before you've even had a chance to patent it or announce it to the world. So this happened to me. I just got back from Seattle in November from taking Valve's Steam VR tracking license course, and we were working on designing a universal tracking puck that we would be able to use with the Talaria locomotion wearable, so that it would be room scale motion captured, and then when you weren't using it as a locomotion wearable, you could take it off and put it on your keyboard, you could put it on your headphones, you could put it on your waist, you could motion capture your cat. And so we were making prototypes out of Play-Doh, but the left was what we had first tried as a first iteration. Then the second one over was what we were thinking, this will be a good next shot, and then that was our simulation on the right. And then HTC made an announcement at CES that year, and they released some Vive trackers that they look pretty similar. And so that was pretty validating. We were barking up the right tree at the very least. But it was at first a little defeating that we had been putting a lot of sleepless nights into developing this kind of tracking puck, and then HTC comes out with one because, I mean, we probably wouldn't have much of a chance competing with HTC on a tracking puck. HTC's got it pretty well together right now. But then we took a step back, and our solution here was, if you can't beat them, join them. So we're developing with the Vive trackers now, and that's really not a problem at all. We're enjoying it and making development a lot easier. It's one less hiccup that we can make on our end. And then other possibilities, like, can you solve it better, for example? So maybe there's a couple of different idiosyncrasies between what your goals were for your development and what this company that came out with something similar is doing. And maybe you can solve this problem better. Maybe you can sell it for half the price, something like that. Maybe it's still worth pursuing for you. Alternatively, can you guys team up? Can you guys collaborate? Can you join efforts together? Lastly, if neither of those sound feasible to you, then are you still passionate enough to work on this problem that it doesn't matter that somebody else made one? Can you go ahead and build one yourself still for your own self-interest, just like out of personal interest? Because that's still valuable, and you'll still be able to teach a lot of people things, and you'll be able to learn a lot of things, and there might be a lot of good that can come from it that could end up in collaboration with the other guys. Another big thing is that hardware dev costs money compared to a lot more compared to software dev in a lot of regards, because you're constantly buying more and more components. So this solution, the way that I've approached this problem has been comparing it to the cost of university here in America. An average American college course costs between $1,000 and $3,000 per course. And so to put that in context, about a semester would be somewhere between $5,000 and $15,000. So by the time you've spent about $2,000 on prototypes, and conferences, et cetera, once you've invested about $2,000 in this kind of stuff, take a step back, make that be a checkpoint. Do you think that you've learned more from this money that you've spent and what you've done on your own personal interests with that, with what you've done than compared to a university class? If you think that you've learned more electrical engineering on your own than you would have in freshman ECE, then I think that that's a pretty good investment, and I think that's justifiable. So don't be afraid either that if a microcontroller costs $20, that might sound like a lot when you're not in the hardware industry at all, and this is just you getting started. But to put it all in perspective, again, just think about what you'll be learning from this and the cost of that knowledge. These figures in isolation might seem daunting, but in the whole grand scheme of things, it's pretty good. And lastly, with all this information, it can sound a bit overwhelming. You're going to be kind of becoming a jack of all trades being a hardware dev. There's a lot that you're going to be learning here, and you might want to start incorporating just plenty of different sensing devices into your hardware and things of that nature. And they're going to be complicated, and they're going to be poorly documented, and it's going to be a frustrating adventure at some points. So how can you avoid being overwhelmed? Definitely take it all in parts. When you're learning, isolate problems down to individual issues. Again, it's always good to go back to just making a blinking LED if you're ever too overwhelmed with anything. And then, yeah, like I said, you'll become a jack of all trades from this. And once you truly do conquer one of these problems, then it'll feel really, really rewarding from that. So that's all my talk. If you guys have any questions, I don't think we have time for Q&A, but I'll be standing outside at the end, so please come on by and chat me up.